welcome everyone to this week's webinar. One of the challenges we have in Wi-Fi, and one of the most important things, is figuring out a way to get our signals to propagate across our environments. And obviously, we do that by leveraging antennas, and most of the access points that are sold into the market leverage internal integrated antennas built into the access points themselves. But with that, we lose a lot of the control and dexterity to direct the signals to where we want it, right? So one mantra that I'm a big fan of is following the philosophy when designing and directing RF energy is cover what you want while not covering what you don't want. And in order to achieve that, we need to be very selective with the antennas that we use. And this takes us down the path of moving from bad to better to best in selecting the appropriate antenna, which often requires use of external antennas, right? So we're very excited for this webinar here to talk about best practices and how we can choose the most appropriate antenna and then position and place it in the location that provides the coverage that most benefits our Wi-Fi designs.
Thanks, Troy. And a quick round of introductions from the Ekahau side. You've got myself and Troy here. We both look after product marketing and ECSE. And we've got Dale from our amazing sales engineer team. He'll be helping out with replying to some of your comments in the chat and a few of your questions in the Q&A. And typically we would have Stu here, but he's technically on annual leave on holiday at the moment. But you never know, Stu. We thought he might have popped in, so we kept him on there now. But the real star of the show and our guest speaker for today is Mr. Dennis Burrell. So Dennis, how are you doing?
Hey, I'm great. Good morning, good afternoon, and good evening to everyone that's on the webinar based on the times that we saw in the chat. So great to be here. It's been about a year since the last time I've been here. So it's awesome always to come on board and talk to you guys.
Yeah, great friend of the show, Dennis. We always love it when you're here, and so do our webinar attendees as well. Always going to get some really good insight. So before I pass it over to you and you're going to take everyone through your slides today, we just wanted to let everybody know that we are going to be hosting our annual virtual Ekahau Wi-Fi Day event for 2025, which is going to be on October 2nd. And if you want, you can get registered nice and early by either scanning that QR code or clicking on that link that Jacob has kindly dropped in the chat for us now. It's going to be a fantastic day. We're going to be bringing you so many great updates, not just from an Ekahau perspective, but we also have some Ookla product news that we're going to be sharing with you on the Wi-Fi Day event as well. And we're going to have a big giveaway. So giving away a Ekahau Wi-Fi toolkit and a seat in one of our ECSE classes. So lots of great reasons to get yourself signed up for the Wi-Fi Day event this year happening on October 2nd. So with that, Dennis, what I'm going to do is I'm going to stop sharing and I'm going to pass it over to you, buddy.
Okay.
So you should be able to take control now.
Let's see. Let me know when you can see my screen.
Yep, perfect. We can see your presentation in PowerPoint ready to go.
All right. So once again, hello, everyone. Dennis Burrell. So a lot of you guys know me from Dennis Burrell at Ventive, but now Ventive is a part of Hubbel, so I'll be Dennis Burrell from Hubbel. So just wanted to give a little info on that. So now I'm under the Hubbel umbrella, or Ventive is under the Hubbel umbrella, as well as a Celltex. So two competitors coming together to make third-party antennas great. So once again, welcome to the webinar, and I'm going to talk about external Wi-Fi antennas 101. Now, my Twitter handle is TGI Wi-Fi Guy. For those that don't know and don't follow me, so give me a follow. I usually post there sometimes, but just wanted to let you know what that handle was. So one of the things that we want to look at when I'm going through this is I'm going to give a brief background on the antennas, why you need antennas, and the different scenarios where you want to use external antennas. And then based on that, we're going to have some live designs to show, and then we're going to move into some common misconceptions about external antennas. So why do we need these why do we need antennas in general, but more specifically external antennas? The antennas are the central part of the design. They keep RF where you want it and concentrate in the desired direction. As Troy mentioned a little earlier, good, better, best. I would look at it from that perspective as concentrating the Wi-Fi in that direction. You can block Wi-Fi where you want it. Reciprocity, you can increase the ability for client devices and APs to hear each other using external antennas and higher gain antennas than you typically see on your APs with internal antennas. You can increase density and aggregate throughput, and you can also reduce co-channel interference by shaping the RF. That picture to the right just shows us some deployment of some high gain antennas with on our colo mount. So it's a colo mount where the AP is on the back side. Then you have an antenna tray with the antenna on the front, and the antenna cables are wrapped on the back side of the tray. So it's like a seamless design. So that's just a one way for external antennas in an outdoor environment. So how does RF behave? Excuse me, guys. So RF behavior of an antenna is dependent on the type of antenna used in your design. Omnidirectional will provide 360 degrees horizontal coverage pattern versus a directional antenna. And this just shows some patterns of directional antennas and omnidirectional antennas. With the directional antennas, the high gain, basically what you're doing is you're pushing your signal in a specific direction, right? So you also have low gain ones, so you're pushing it in a specific direction, but the beam width is larger. So basically, what do you think of when directional antennas? The more directional the antenna, the higher the gain, the lower the beam width of the antenna. Conversely, with the lower gain directionals, you're pushing it in the direction, but you have larger beam width. And then the same with omnidirectional antennas, right? So higher gain, you have less of a vertical beam width as opposed to a lower gain antenna where you have the high beam width. And as you can see, it pretty much shows nulls in the 0 and 180 degree pattern. It shows nulls there because with omnidirectionals, there's a null in the center. So when you're doing antenna design, you want to talk about specific parameters. And here's a few that I think everyone should be aware of, specifically when you're designing with that external antennas. I just talked a little bit about beam width, right? So the beam width, the theoretical beam width is stated as 3 dB down from the peak of the gain of the antenna when you're doing a pattern of showing a pattern of the antenna. So in this case, 3 dB down is 13 degrees off of axis. So you do 3 dB on each side, and that comes out to 26 degrees as far as the beam width. Now, there may be some instances when you're looking at the beam width of an antenna that beam width is slightly skewed, it's not symmetrical. So for instance, if this one, for instance, maybe on one side it was 15 degrees, and then on the other side it was maybe 11 degrees, you still have that 26 degree beam width because it's predicated upon that 3 dB drop off of the pattern. And then your side lobe level. For side lobe levels, this is really important when you're looking at high density designs, right? Because you want your main lobe to be a certain level above any of the side lobes of the antenna. And the side lobes of the antennas are just different basically harmonics of the antenna that's coming through. And you want to have that main lobe level as the highest point, and then anything below that. So for instance, if you're designing in a high density network, you want those main side lobe levels down at least 10 dB 10 to 12 dB down from your main, as far as not to have any interference as far as your high density design goes. And then your front to back ratio, that's the amount of energy you're pushing out the front of your antenna compared to what's coming out the back of the antenna. This is also important for high density designs as well, specifically as an example, stadiums, right? So in a stadium design, for instance, if you're doing, say, a side-to-side design where you have antennas on a handrail or an enclosure in the handrail, and you're pushing to a specific section, you want to push the energy to that, say, that section to the right, and then the back lobe, you want it minimum to that section going to the left, because there's going to be another antenna covering that section. So you want to maximize your front to back ratio. So in this example, the front to back ratio is the peak of the antenna and then 180 degrees from that peak. And that's how you calculate the front to back ratio. So in this example, as you can see, the front to back ratio here is 25 dB.
Hey, Dennis, I just have a
Yes.
question for you about this on front to back ratio. And you said maximize that ratio. And in the example, you have there, what would be an ideal front to back ratio? Where would you kind of draw the line and say, hey, this has gone too far. May not be the best antenna to get the job done.
So for front to back ratio, typically at 2.4, we're talking about at least 12 to 15 dB front to back ratio. And then in the 5 gig range, we've seen on the order in some of our designs around 25 dB, 20 to 25 dB.
Cool, thank you.
Mm-hmm. And so then one of the things you also want to take into account is your antenna testing. So when you look at any spec sheets, when they show the patterns, most likely those patterns were tested in the anechoic chamber, right? So the reason why you test in the anechoic chamber is a totally isolated and quiet environment. So you're only seeing the patterns of the antenna with no interference or anything like that, right? So we use it to make sure our design specifications for the antenna are met. If they're not met, we do iterations of the design, right? And then generate VEX files based on these to be added to Ekahau, to be added to the database. So the files that we send to Ekahau is based on our anechoic chamber testing in that environment. And this just shows a 2D and a 3D pattern of a high gain antenna. And then the center is a chamber that's out there that we use to do some testing. It's called the Stargate chamber. And that picture shows the our junction box antenna that we were performing some testing on, just to give an example of what that looks like. So if you're using external antennas in your design, right, your Wi-Fi design, you want to know when should you use external antennas. So what are the environments when external antennas are used? So these are some of the environments that I look at when I'm using external antennas. So when ceiling heights are higher than 25 feet, I typically switch from a omni antenna to a directional antenna. So for omni antenna, if I'm going to give a little example. So typically when we do omni antennas, that radiation pattern kind of looks like a donut, right? So you got your donut here. The thickness of the donut is your vertical, right? The whole of the donut, that's that null at 0 and 180 degrees. And then that circumference is your horizontal beam width, right? So that's that 360 pattern. So that's that omnidirectional pattern. Now, when you have this mounted on a wall, that donut or that hole, right? That's that null. And as you raise that antenna, or as you mount that antenna higher, what you find is that null down on the floor gets wider. So we feel that at around 25 feet max is where we want to switch over from an omnidirectional to a directional. So the hole, as it gets higher, it casts a wider null pattern. And even you do design for coverage overlap and stuff like that, we feel that at 25 feet that you want to switch from a omni to a directional. So I actually have a actual donut as my example. Oh.
Yeah, Dennis, you're making a lot of people hungry in the chat now. Everyone's craving a donut. I'm not sure if you're keeping up with what people are saying, but yeah, a lot of people now want to go get themselves a nice donut.
So the next place is when propagation characteristics are affected by building or natural obstacles. If you have, for instance, say an open area in a building and they have trees or they have sculptures or anything like that, or in some instances like water fountains or a lot of glass. Then also hallways along corridors, aisles, and other structures with spaces in between, and falling into that category is also like your warehouses. In temperature limiting areas or environments, for instance, in freezer applications where you have to get Wi-Fi inside of a freezer, for instance, at a grocery store, at a Costco's or something like that in the produce, you need to get coverage in there. And then, of course, high density deployment networks. And then also where aesthetics are important. You don't have the capability of putting anything on the ceiling. So you can go above the ceiling and come with what we call our small form factor antennas and put those on the ceiling or on the wall. So just as an example of using an external antenna where ceiling heights are greater than 25 feet. This just shows a 18 dBi directional antenna, 5 gig antenna that we did a design for and was doing some testing of this antenna at 170 feet. Now, this antenna this testing was done in Detroit at a Ford Field, Detroit Lions stadium. So this just to show an idea of something where it was higher than 25 feet. So like I said, the antenna height was 170 feet. And then another deployment for high density networks for large public venues. What you see there is a picture of our enclosure, our handrail enclosure. Now this enclosure has 2 APs in it, and then this has 2 directional antennas mounted back to back. Now this is where that front to back ratio definitely comes into play that we were discussing earlier, because you don't want that back lobe going into, say, that bottom of if you're looking at the heat map, you don't want that going into the bottom area where that AP is doing the coverage, as opposed to the top area where the original AP or this first AP is doing the coverage. So this is one of those cases where that front to back ratio definitely plays a part in your design. So let's look at a couple of antenna visualizations using Ekahau AI Pro.
All right, I'm gonna steal the share from you, Dennis. So bear with me a second. Hopefully you guys and girls see my screen.
Yeah, we do.
Amazing. So if you're not familiar, this is our Ekahau AI Pro Online solution. And what we've got here is a warehouse environment. And we've got a warehouse environment that's got a couple of different spaces. So I would say 3/4 of the space is the typical kind of racking, shelving areas. And then this left-hand side here is kind of like the loading bay area where you'd have some pallets stacked up. And what I've gone ahead and done is I've placed a couple of access points using some external antennas. So why don't I first of all show you the one you had on the list was the Axeltex antenna, which it has the 8 dBi gain with a missed AP47E. So I believe that this is actually this type of access point and this type of antenna. So Dennis, typically, where would you like, how would you use this antenna in this environment? Is this something you would normally mount to the wall? Would you normally put it on the ceiling? Like, what would you do?
Yeah, so for that one, we would mount that to the wall, so and shoot it down the aisle. Um, and then also we would use that as in long corridors as well when you need coverage down a long corridor. So that would be a wall mounted.
Okay, cool. So one of the things you can actually do in Ekahau Air Pro Online, if you want to visualize the antenna that you're planning to use, you can actually kind of see it in 3D here. So you can kind of see that the direction of the antenna, the energy is going to be focused in that particular direction, and make sure it's kind of like the one that you are looking to use. And Dennis did mention that you would put this on the wall. So I have configured this to be installed on the wall. If I wanted to change it to be on the ceiling or on the floor, I can do that here. And we can also adjust the angle of tilt. So currently it's set to be at 10 meters height with a 15-degree kind of down tilt, but I can slide this down a little bit more. And what you should see is now the coverage actually gets stronger directly underneath the access point. The more aggressive you get with the tilt, the better the coverage it will be directly underneath the antenna. However, further away you get from it, you can kind of see that the signal gets not quite as strong. So you, depending on what height you plan to install the access point and antenna at, this is where you'd want to configure the tilt of the antenna as well to make sure you're providing that level of coverage that you're looking for. But Dennis, I do wonder, not that just because you've got this type of antenna in this environment doesn't necessarily mean that you always have to use it in this way. I have seen in the past in some examples that maybe you could use this not just against the wall to shoot down the racking aisles or down long corridors, but if you, let's say you have like these pallet areas, if I was to move this over here, for example, and instead of having it on the wall, we could maybe put it on the, like mount it like from the ceiling shooting down, and we could even make it go up a little bit higher perhaps, because maybe we wanted to, focus the energy down to control the size of the RF coming from that antenna. So we was maybe just focusing it at some pallets or some block of seats rather than using like an Omni that would go very spread out throughout the entire
Yes.
environment.
Yeah, exactly. And with this antenna, it has more of a symmetrical coverage pattern. So that's actually great for overhead, for an area like that when you're trying to get that type of coverage from overhead over in that area to the left where you have it now. And then just based on the height, uh, it gives you whatever that coverage pattern is, and varying that height, it either makes it larger or a smaller or more condensed coverage pattern.
Yeah, so let me just turn on our 3D view so you can kind of see what we've got configured over here. So we can see that the walls and the racking aisles probably go up to about 15 meters in height, but then we've got these palleted areas over here configured, I think, for around 2 or 3 meters, and we've configured like a steel beam to run through the environment. So yeah, we can see that's now shooting down, and it's controlling the size of that cell rather than it just kind of like bleeding out everywhere, which is fantastic. And we have a couple of other antennas that you wanted to discuss potentially as well, Dennis. So if I select this one, this was the other one on your list. So this one is on the ceiling, currently configured for just under 14 meters height. And if we take a look at the antenna pattern down here, we can see that this is this type of model antenna. So you could use this if you wanted to maybe put an access point in the middle of the aisles and try and cover down the aisle from the center from either side. Is that correct?
Yeah, so the advantage to this to this antenna is its wide horizontal beam width. So this was designed specifically for warehouse aisles where you have about 115, 120 degree beam width. Yeah, horizontal beam width. So when it's overhead, it can cover that entire aisle. So you can cover an entire aisle with this antenna with just one antenna in the center of the aisle.
Nice. And I know that you guys Hubbel with between Bentev and Axeltech, you have an even more higher gain version of the warehouse antenna that is
Right.
actually 13 dBi gain. So if you've got super long aisles, then you can use this in the same kind of approach and it will cover even further.
Yes. So one of the antennas we have what 13 dBi It could cover in some of the heat map designs, to predictive designs that we've done with heat maps. Yeah, specifically that one right there. We were able to cover an owl that was 320 feet long with just
Wow.
one antenna in the center of that aisle.
Yeah, that's a great amount of distance that you can cover from that, because sometimes what I've realized is when you're doing warehouse deployments is you might come up in a situation where on one side of the warehouse you'll be able to physically mount and install an access point and antenna and shoot the coverage going from, let's say, right to the left. But if you needed to provide coverage from the left-hand side going down towards the right, sometimes there isn't anywhere to install to. So it can be really tricky to kind of do that kind of approach from shooting from both sides. So having the option to be able to install from above, which is typically easier and more feasible and less likely to be hit by forklift trucks, you can then cover the aisles with this kind of solution and approach, which is a very helpful additional way to be able to provide coverage in these kind of scenarios.
Yep. Yeah, exactly. And then, like you said, we have that one that will cover the entire aisle. Now that's your top-down approach, and then the earlier one that you had on the wall, typically depending on the length of that aisle, you can put it on the wall to cover it, but you can use one for that aisle. But if that's not the case, then you can do if it's a longer aisle where you don't provide that coverage, you can put them on each end to cover that one aisle. Or if it's long enough, typically what some of the things we do is when we stack the APs, for instance, for that aisle coverage, right? You have the AP on the right hand side. Then that next aisle, we would put the AP on the left hand side so that we're shooting down the opposite ends.
Yep. That is this kind of staggered approach.
Yes.
Yeah, very, very good. I did notice someone in the chat a little while ago, or in the comments asking about total output power or EI, or like total power coming out of the access point. And I do think this is an important thing to mention here and to be aware of. So when you use Hubbel antennas, you will notice that in the product name or on the data sheet that they'll have a certain amount of antenna gain. So what that means you need to kind of be aware of then is how you configure the transmit power of your radios, because what effectively happens is that you get the transmit power of the radio. So for example, here I've set the transmit power to be 7, but you notice here that the EIRP is actually 17. And what the EIRP means is it's basically taking the passive gain of the antenna on top of what the transmit power is set to, and that is going to give you what the total output of that power of the access point and antenna is going to provide to you. And this is something that you need to be aware of, because wherever you're designing or deploying for, they will have different local regulatory rules which will stipulate the maximum total output you can have on specific frequency bands and specific channels. So for example, here, if I was to try turning this up to 20, Ekahau will flag straight away saying, hey Matt, this is not allowed by the regulatory domain. But just something for you guys and girls to be aware of, because this can affect, obviously, if you're configuring a transmit power level that plus the antenna gain to give you that total EIP would be too much, then you might not be getting that specific coverage or expected output that you're planning for your network. So just something to bear in mind there.
And one of the things I like to think about is when you're modeling antennas or trying to envision it in your head, is I like to imagine the energy as a balloon, right? And you can change the size of the balloon by increasing the transmit power that Matt just showed, right? So if you want a bigger balloon, increase the transmit power. But with antennas, they're not making bigger balloons. Antennas are just changing the shape of that balloon. So the bigger the gain on the antenna, the more you're squeezing or focusing the balloon in a particular direction, but the actual volume isn't increasing. So when you're picking those different antennas, whether it's omni or a highly directional, that's one thing to think about, is just how you're squeezing the volume of that balloon. Another question that's come in the chat just while we're looking at this model here is, one of the questions is just for frame of reference, how long are the aisles of this warehouse? Because we see the coverage propagating all the way down the aisle. Just what's a sense of just how long these aisles are?
Good question, and I can't remember off the top of my head. So let's just have a look here. If I was to rescale this, these are currently around 65 meters. So if you want to know what that is in feet, I will change the option. Where do I do it? Oh, you know what? The thing is just blocking it. I can't actually change it. Now, who can do the quick conversion of 65 meters into feet? Because I'm not too good. There we go.
It's
I
about
you're
214.
probably wondering why I couldn't click on it, but there's like a zoom thing here that you probably can't see on your screen. It says annotate. So I couldn't click on this little icon here. So I can change this 1 second. Meters to feet, and that is about 210 feet. Hopefully that helps give some reference. Did people say that in the chat? Quite right? Yeah, okay, good. Well, some people were quite off. Jacob, 133. Uh, um, okay. Well, was Troy or Dennis, was there anything else from the chat or anything else you wanted to see that we've got currently shown here in Ekahau AI Pro Online before I pass it back over to you, Dennis, to go over some common misconceptions?
Someone in the chat was asking about height or typical height that these antennas are mounted. So the high gain, that high gain antenna, warehouse antenna, typically the height where we get questions or want to mount it is around 35 feet.
Yeah, and I've got it currently configured here for 45, and it's still easily covering the aisle.
So related to that question, you mentioned earlier that at 25 feet, that's sort of your tipping point to start looking at directional antennas.
Yes.
Just made the comment that the ideal spot was sort of 35 feet. So my question is there a range that's too high? Is there something that would you'd start to feel uncomfortable with if there's a ceiling height or a distance that you're trying to shoot that you're like, maybe we should find a better position for the antenna that we can get closer to the client?
Great question, Troy. So typically what we start looking at once we get up around, typically we're at 35 feet. We've had some about 50 feet, but typically what we start doing after that is trying to just do what that coverage area would be. So do like a trigonomic calculation as far as what the coverage area would be based on that beam width, and then take it from there. But then if you're looking into if you're looking into, say, doing it on AI Pro, and you're starting to, play with it at different heights, you'll start seeing how the coverage may start changing and may start going across the aisles or something like that, right? So then you want to kind of adjust it, because if you're trying to just cover that one aisle, so more so, and when it's an AI Pro, as far as the height, that's more so something that you want to do as far as playing with it. But typically, I think the most that I've seen these antennas being asked to be mounted at is around 50 feet.
Brilliant. Thanks, Dan.
Okay, anything else before I stop the share and pass it back? We can always come back to this once Dennis has covered his slides, and if there are any more questions around AI Pro and modeling out any of this. All good? Okay, Dennis, I'm going to stop sharing and pass it back to you because I'm looking forward to seeing these misconceptions again.
Okay. So we're back.
Yep.
So common antenna misconceptions. The screen is blank, so I guess there are no misconceptions about antennas. So
It's all that
I
straightforward,
think we
is it?
might be done, Matt. But actually, I wish that was the case. But there are always some misconceptions. So we'll go over some misconceptions with you guys. So does a higher gain antenna equal a better antenna? So high gain antenna will be a better antenna in my environment and will provide better performance. That's fiction, right? So one of the things that we want to know is that, in fact, certain deployments at a high gain antenna can help, but if improperly designed for, excuse me, properly designed for can increase noise in your environment and potentially leave holes in your coverage. So if you want to look at that, the design of the antenna depends on the need. So right here that we looked at for in AI in Ekahau is that we took two antennas, right? We took a high gain antenna, a 12 to 14 dBi antenna, and then a lower gain antenna, 8 dBi antenna. Like I mentioned earlier, the higher gain antenna has narrower beam widths compared to a lower gain directional antenna. So it just depends on what your coverage is and what you want your coverage to be. So in this instance, if you were just trying to cover the football field, that lower gain antenna would do the trick because it gives you more coverage of the field than the higher gain antenna. The higher gain antenna is covering the field, but it's also going up into the stands. So that just tells you right there that not necessarily that that higher gain is better. It just depends on what you're trying to cover and your design parameters on what you're trying to do. A bigger antenna equals a stronger signal. If the antenna is physically larger, it must be a higher gain and provide a better signal at my client device. That's fiction. In fact, there are many contributing factors to the size of an antenna, such as gain, beam width, efficiency, the polarization, the element counts, how it's tuned for frequency, and many others. I had mentioned some of those earlier as far as important parameters like that, the gain and the beam width. So just to give you an idea, so you're looking at two antennas with somewhat similar gains. The antenna on the left is what we call our small form factor line of antennas. That's what we call our femto patch. It's a 6 dBi antenna compared to one of our antennas that's 4 or 5 dB that has 10 ports. It's a larger antenna, but it has the same gain. So it just depends on what you're looking at, right? So that just shows you that bigger is not better. We can pretty much get the same thing. So like I said, the one on the right is for a radio that has 10 ports. The one on the left is for a radio that has 4 ports. And it depends on, for instance, what type of beam width you're trying to get. And if you're trying to keep the beam widths consistent over the entire frequency range of the antenna, that may cause for a more stringent design, which would make that antenna larger because there are more elements when you're going through the design process. External antennas are always better than internal. That's fiction. And external antennas are always the better choice when designing a network. While there are many environments where utilizing some form of external antenna is beneficial, the integrated antennas and modern APs can perform as well or better than external in many environments. So Troy mentioned earlier that a lot of the designs, we're kind of estimating that around 90 to 92% of the APs sold have internal antennas in them. So that kind of gives you an idea of based on the environment where you may use internal antennas, but we're talking about external antennas, and there are those environments. Like I mentioned, I gave 6 or 7 areas where you want to use external antennas. Antennas operate uniformly across all tuned frequencies. My antenna of choice will perform identically no matter what channel frequency band is being broadcast. That is fiction. The fact is, in an ideal world, this would be true. However, the exact performance of an antenna will vary across any frequency band that is tuned for. So what we have here is that we have an antenna, a tri-band antenna covering 2.4, 5, and 6 gigahertz frequencies, right? We show the gain and we show the efficiency. Now, the chart that you see is the VSWR, the voltage standard wave ratio, and this is basically the amount of power transmitted through the antenna versus the amount of power that's reflected. So we typically look for a 2-to-1 VISWAR. That means that around 90% of the power is being transmitted through through the antenna, with minimum being reflected back. And as you can see over the VISWAR, those VISWAR numbers vary across the frequency band of operation. So conversely, if that's varying across the frequency band of operation, if you look at the gain and the efficiency, that varies as well, because that VISWAR is varying. So that just tells you that the gain varies across the band depending on the frequency and how it's designed. And this shows those bands, the 2.4 and the 5 and 6. Directional antennas only cover a small spotlight area. So we discussed that a little bit earlier about the directional antennas. Directional antenna will act like a spotlight and only provide coverage in a small cell-based area. That was fiction. In fact, there are many types of directional antennas. Some are very narrow, symmetrical being width, like referenced above. Some can be very wide, and asymmetrical, being able to cover wide swaths of area. I showed that earlier slide of the football stadium with a more of a symmetrical beam width antenna, which was the high gain, as opposed to a non-symmetrical, which had a wider horizontal beam width coverage. So right here we have 2 antennas, right? So if you look at it, the top one is symmetrical. And by symmetrical, that means that the vertical and the horizontal patterns are the same beam width. That's what we mean by symmetrical. And then at the bottom, we see asymmetrical, where the vertical and the horizontal beam widths are different on the antenna at the frequency bands of operation. So that's the difference between a symmetrical and asymmetrical. So it just depends on what your design is calling for. Typically for some high density coverage, depending on if you're doing overhead or side to side. Overhead, you typically look at more of a symmetrical type of design for that spotlight area. And then on the side to side coverage, which is antennas on the handrail, you want more of a wider horizontal beam width because you want to cover more seats. So changing the antenna won't help AP client power mismatch. Even if I change to an antenna that will provide coverage at a further distance, my client devices still won't be able to communicate back to the AP due to AP client mismatch. The fact is, a high gain antenna causes a bidirectional increase in transmit and receive sensitivity, which can help client devices communicate even at further distances than normal. So this is pretty much what we call antenna reciprocity. So if my transmit antenna can get to the client device, then that client device will be able to talk back to that antenna that's transmitting to it. And this just shows how we increase transmit receive sensitivity. The one on the right is transmitting, and the one on the left is receiving. All antennas are created equal. It doesn't really matter what antenna I put on, they're all basically the same if they have the same gain and beam widths, which is fiction. The fact is, many inexpensive antennas on the market may advertise certain specifications, but their actual performance can differ significantly once deployed. They often also have lower quality standards for efficiency, VISWAR, and materials compared to trusted brands. So quality is a big issue with less expensive antennas. You definitely want an antenna that's going to last and have a long warranty period. And then you want a design where the performance is consistent across the frequency band of operation. So in a nutshell, basically what we're saying is don't get your antennas from Temu. Get your antennas from a trusted source like Hubbel. Antennas provide more range at lower frequencies. That is a fiction because a multiband antenna will have more range at its lower frequencies compared to its higher frequencies, when in fact, lower frequency range waves will generally propagate through materials more easily than higher frequency wave. So you see, when you're doing your Ekahau and you're in it and you're going through walls and stuff like that, if you notice, your 2.4 gigahertz will travel through the walls better than your 5 gigahertz waves, as compared to your 6 gigahertz. The higher the frequency, the more attenuation when it goes through walls and those types of things. The amount of power received is directly proportional to the effective aperture of the antenna. So one way that you get around that is by increasing the aperture at the frequency to get more performance or more transmission and gain through it. So typically, this chart just shows how do you calculate the effective aperture, and you see that at 2.4, the effective aperture compared to 5 and 6 gigahertz. So you would have to have a much larger antenna with a much larger aperture at 5 and 6 gigahertz to get that performance as far as within the coverage, going through going through attenuation or going through walls and stuff like that to perform the same at 2.4 than at 5 and 6. All right, so that was a brief external Wi-Fi antennas 101 slightly deep dive. Once again, Dennis Burrell, there's a QR code if you want to link up to me. And thanks for listening.
Yeah, thank you, Dennis. And yeah, people should definitely follow you if they get the chance. But Troy, let me just share my screen. Maybe because I know a few people joined late, but maybe you could just let them know about this amazing event coming up soon.
Yeah, absolutely. Before anyone starts dropping off, and we are going to run through some Q&As first, but in case you joined late, we just want to cover again and announce that we will be hosting Wi-Fi Design Day 2025 on October 2nd. This is a virtual online event. You can register by scanning the QR code there or hit up the website directly, type that in. There is no cost to attend this event, right? It is absolutely free. You're donating your time. What we're providing back to you is a wealth of information from a lot of excellent speakers and presenters. But again, Wi-Fi Design Day, October 2nd, registration is now open for that, and we hope to see you there.
Yes. So Dale, maybe if you come back, my friend, and you can give us some of the juicy questions from the Q&A.
Absolutely. So one of the questions that we see posted here is, for a warehouse environment with ceilings at 40 feet high and high racking up to about 37 feet, what type of directional antenna do you recommend? What's the gain recommended for the antenna? Transmit power level recommended with this external antennas?
So it's a high high attenuation device, high attenuation appliance. Is it appliances? What's in the racking area? If it's something that's highly attenuated, you definitely want to go with one of the higher gain antennas, like what Matt is currently showing.
Yep. So we've got one of your access points and antennas configured at 40 feet high, and these racks are coming up to just around 39 feet as well. So pretty much just like what was being asked. So this shows that you can leverage this type of antenna. So the Ventev TerraWave version here, and put it down in the middle of the aisle and cover either side. And Dennis, you said that you had racking aisles before that spanned around 320 feet. Is that right?
Yes.
Yeah. So these ones here, they basically come up to about 100. What was it we say? 200?
Yeah, 210, I think you said something like that.
Yeah, it depends on who you ask. If you ask Jacob, he says 130, but 200 and 210. So yeah, this is quite quite easily capable of covering that. And the other question I had was around the transmit power. So the transmit power here is currently set to around 5 dBm on 5 gigahertz and 2 on 2.4, but you can see that EIRP is up to 15 and 18 because of the gain of the antenna. So this could be a really great feasible option for covering these racking aisles. But Dennis, alternatively, if not, correct me if I'm wrong here, but using this type of solution for those aisles, shooting from both ends with this type of antenna as well, could also be an option if you've got really long aisles that are spanning quite significant distance in height, but also in the width.
Yes, exactly. In some instances, in some of these warehouse environments, they can't go above the racks or above the aisles to mount the antenna. So then we go with the antennas mounted on the wall, like you have there, shooting down the aisles. And then that's when you want more of a symmetrical one for that, because that one that's that warehouse antenna that has that 115, 120 horizontal beam width wouldn't work in that environment or in that scenario as far as being mounted on the wall.
Yeah. So I saw Mark mentioned as well in the chat, some of the reasons why you would use external antennas. And it doesn't necessarily just come down to physical mounting of where you can mount them and obviously trying to get that good coverage and good capacity, but sometimes it can just be an aesthetic reason. You might work in or manage a environment that aesthetics is a huge concern, and being able to use and deploy external antennas that can be more subtle or easily blended into the environment is a really important factor as well, isn't it, Dennis?
Yes. A lot of the new green space buildings and everything that's coming up, they don't want to see anything, right? So that's where you start looking at aesthetics, small, can be hidden or camouflaged or those types of things. So there's a lot of things that we look at where we use external antennas for those types of things. In the outdoors, some of the things we talk about is what we call Wi-Fi street furniture. Put in external antennas and bollards and light globes and those types of things. So aesthetics definitely play a role in design and deployment as well, Matt.
Yeah, absolutely. And then Alonso just asked in the chat, what is the attenuation set for the warehouse racks that we've got set here? So you'll notice it's 18 dB slash M. So that means it's 18 dBs per meter squared. So the bigger the distance you draw for your attenuation object, the more impact it's going to have on the attenuation signal. But I don't know about you, Troy, but when I'm designing for warehouse racks, typically I know that when the racks are completely full of different materials, they will in most scenarios completely attenuate the signal strength of the Wi-Fi. So having an attenuation here of like 18 dB set per square meter will typically reflect what is the most likely attenuation of a rack in an aisle. I know sometimes you're going to have racking that is going to be completely full of entry, sometimes it's going to be half, sometimes it's going to be empty, but what do you think, Troy? Is it best to design for the worst case scenario when it's completely full and attenuating heavily, or what would you say?
So I see both extremes as worst case scenarios, right? So when the racks are completely full, then I would
Mhm.
model it as 18 dB per meter, as Matt's showing. But then you can also quickly flip that around to zero, as if there are no or 1 dB, just to represent empty warehouse racks, and just see how your signal propagates. So as inventory and product is being moved in and out of the warehouse, you can have both equally bad situations, right? If the racks are completely full, your RF energy is very constrained, and you want to make sure that you can propagate up and down the aisles as well as you can. With empty warehouse racks, CCI becomes a big problem, right? And so that's where you want to be very selective in getting some highly directional, highly focused antennas. So as that inventory is pulled off the shelves, you're still minimizing CCI in your warehouse environment. I also sometimes use different types of shells with different attenuation models for different warehouse racks. Because ideally, in a warehouse rack, they'd put similar materials on the same shelves, and that'd be a constant process. But other times, new inventory shows up, and so they swap out the materials. So one day it might be an 18 dBm per meter warehouse rack. The next day it's only a 5 dBm, just based on the material that's in the rack itself. So a lot of it depends with warehouse racks, but you can very easily model different attenuation values within AI Pro Online, which allows you to create those what if scenarios quite flexibly.
Yep. Uh, and then someone just noticed that our heat maps are alive or breathing in AI Pro Online. That's because our SOAs are moving. Huh? Is there any other questions, Dale or Troy, that you saw in the Q&A that would be helpful for me to have AI Pro Online open the show?
Not particularly around, having that open, but there are some
Okay.
other questions. On one particularly for Dennis. It says, just curious, if all the rules and with all the rules and regulations around 6 GHz use, has any of that affected your work? And if so, how?
Yeah, 6 GHz outdoors has definitely been challenging from the perspective of the AFC, right? And getting antennas to work with the OEM's access points, right? So we've come up with antenna designs. For instance, with Cisco, right? With Cisco's 9163, Cisco uses the SIA antennas. So it took a while working with them to come up with a code where you could a software upgrade where you could use non-SIA antennas, right? So that was one of the biggest challenges that we had as far as trying to get our antennas to work on those APs. And then just in general with the Matt and Troy had mentioned earlier, the EIRP with standard power and the antenna gain, and making sure the antennas are designed such that when it's added to the standard power, it doesn't go above EIRP. So just making sure that we design to those specifications with those specific antennas covering 6 GHz.
Thanks, Dennis. And one interesting question I saw asked. So we one of the participants on today's webinar said that they have a scenario where they cannot mount any access points outdoors, but they need coverage outdoors, and was asking, if they could consider placing an AP or an antenna against the glass to accommodate coverage outdoors. I'm not aware of, any particular model where, that would be good, but do you have anything around that?
Well, that is
So
a
we actually do. We actually did come up with a design of an antenna that you actually can stick onto, you can mount onto glass, right? It has some 3M adhesive, and you actually just attach the antenna to the glass to get that coverage outdoors.
Interesting. How about you, Troy? Any questions that you want to ask?
I was just wondering, Michael had asked earlier just about null patterns based on what you presented earlier. And I was just wondering if you just go into a little bit deeper explanation of where those null patterns come from. Why do we have side lobes, rear lobes? And why can't we just make more of a perfect or idealistic pattern? What contributes to the antenna design with we end up with those nulls?
That's a great question. So a lot of the designs that that we come up with or take into account those types of things is just dependent on the radiators and how you design the radiators and the space in between the radiators, as far as generating those side lobes, right? With the higher gain or any gain antenna. Typically, sometimes what happens is we try to do trade-offs. For instance, if I want a smaller antenna, there's certain things that I'm going to sacrifice to make it smaller, and in that case, that's your side lobe levels and your front to back ratio, where you'll start to see some of those things come into play. Now, if I'm going to go through a stringent design where I want a high density type of antenna design, I want to design so I decrease those side lobes. So that's going to be a more stringent design, but that typically means that you're going to need more ground plane and you're going to need a larger antenna. So it's basically trade-offs between what you're trying to achieve as opposed to the size of the antenna.
Yeah, it sounds like it was many things in Wi-Fi. It's always balancing.
Yes, exactly.
Many different designs.
Definitely trade-offs.
Yeah.
Dennis, there's a couple of specific questions in here that you probably have to answer quite quickly. So Victor just asked, who is the Hubble distributor in Central America, particularly in Costa Rica? Is there somewhere that they can find out this information
Yeah,
easily?
if he reaches out to me, I can get him that contact.
Okay. And then Alex was asking if there is a link or the name of that antenna that you was talking about that can be mounted to the glass.
Yes, tell him reach out to me and I'll give him that part number. I just don't know it off the top of my
Okay.
head.
Dennis can be found easily, especially if you go onto LinkedIn. You can just search Dennis Burrell. You'll see his picture pop up. So if you're gonna find him on there, you can just connect and then reach out and then get those questions answered. But Dennis, thank you so much for your time today. This was again a fantastic webinar. So much great content, and you can see how much everybody in the audience was enjoying the excellent information you could share with us as always.
So I guess I'll finish my Omni donut once we're done.
Yeah, I'm desperate to go get myself a donut now as well. So
Me too.
what's everyone's favorite donut filling?
Yeah, exactly. So here in Texas, we have what's called Round Rock donuts, and there are these donuts, and they're just your standard donuts, but they're orange. So they put
Okay.
some type of orange flavor coloring in them, and people go crazy for those donuts, man.
Troy, do you have a
So if you
favorite?
come out here, we'll make sure you get some, Matt.
Okay. Can't wait. Troy, you got a favorite donut?
Yeah, I've always been partial to apple fritters, and I think that allows me to custom shape the apple fritter. So I don't need to recreate that classic donut pattern. I can create a hyper directional apple fritter, maybe put some apple chunks in the right spots to appease my taste buds for that day.
Yeah.
Yeah. Dale, you got a favorite one?
I'm not really a big sweets guy, but just a regular donut with chocolate frosting or icing on it. Yep,
The classic.
classic.
Yeah. Can't beat a classic. Well, I feel like today's webinar is also going to be a classic. I bet people are going to be watching this over and over again to get lots of Dennis's great insights. So thank you again so much, Dennis, and everyone
Thank
from
you,
the Ekahau
Dennis.
side. But of
Thanks,
course,
everyone.
yeah,
Thanks.
and of
Always
course,
good to be on here.
yeah, definitely. Always great to have you here. And thank you so much, everyone, for staying on and asking so many great questions and engaging in the chat. We look forward to seeing you all in the next webinar. We have a webinar coming up in September, and Roel Dionisio is going to be our external guest for this one. And then we have Wi-Fi Day. So lots of great content coming up for everybody. So looking forward to all of that. And we'll see you all soon.
See you, everyone.
All right.
Thank you.
Peace.